Welcome to Chapter 3, Loops. Loops are one of the most. Imagine you need to print hello 100 times. Without loops, you'd have to write 100 print statements. That's not just tedious, it's unmaintainable. With a loop, you just write 2 lines. Loops are used everywhere in real programs, sending emails to thousands of subscribers, processing every row in a CSV file, checking every pixel in an image, calculating totals from a list of prices, or searching through product catalogs. Mastering loops is one of the biggest steps toward becoming a real programmer. The for loop iterates over a sequence, it goes through each item one by one. The syntax is for, then a variable name, then in, then the sequence, then a colon. Inside the indented block, you write what to do with each item. You can loop over a list, a string, a dictionary, or a range of numbers. The range function is incredibly useful. Range of 5 gives you 0, 1, 2, 3, 4. Range with 2 arguments gives a start and stop. Range of 2 to 10 gives 2 through 9. And with 3 arguments, the third is the step. Range of 0, 10, 2 gives 0, 2, 4, 6, 8. The enumerate function is great when you need both the index and the value together. Let's see for loops in action with 3 real patterns. The accumulator pattern, we start total at 0, then add each price to it as we loop. This is how you sum a list of values. The filter pattern, we check each number, and if it passes our test, we append it to a new list. Finally, the list comprehension, Python's elegant shortcut. Instead of 4 lines, we write the whole filter and collect pattern in 1 line using square brackets. List comprehensions are a hallmark of clean, Pythonic code. The while loop is different from a for loop. Instead of iterating over a sequence, it repeats as long as a condition remains true. This makes it perfect when you don't know in advance how many times to repeat. The key rule: always make sure the condition will eventually become false, otherwise you'll create an infinite loop that runs forever. The break statement lets you exit a loop immediately when a condition is met. The continue statement skips the rest of the current iteration and jumps to the next one. For loops can also use break and continue in exactly the same way. In our first demo, we use a while loop for a countdown. Count starts at 10, and we subtract 1 each iteration with the minus equals operator. When count reaches 0, the condition becomes false and the loop exits. In the second example, we search a list using while with break. When we find the target, we set found to true and call break. This immediately exits the loop without checking the remaining items. The code after the loop checks whether we found it or not. Let me share 4 essential loop patterns that appear in almost every program you'll write. The accumulator pattern starts with a variable at 0 and builds it up by adding each item. The filter and collect pattern starts with an empty list and appends items that pass a test. The find and break pattern searches through items and stops as soon as it finds what it needs. And the maximum or minimum pattern tracks the best value seen so far, updating it whenever a better one appears. Master these 4 patterns and you'll be able to solve the vast majority of loop problems. Great job completing Chapter 3. Let's recap. The for loop iterates over any sequence, lists, strings, ranges, and dictionaries. Range gives you number sequences for counting loops. The while loop repeats while a condition is true, always ensure it will eventually stop. Break exits the loop immediately, continue skips to the next iteration. List comprehensions offer a Pythonic one-liner for filter and collect patterns. In Chapter 4, we'll learn about functions, the feature that lets you organize and reuse your code. See you there!